So, guys, welcome to one more very interesting topic on advanced C programming language concepts. So, in today's session, I'll explain you what are VLAs in C programming. VLAs stands for Variable Length Array. Again, I'm repeating. VLA stands for Variable Length Array. So, what is VLA in C programming that we are going to learn? And I'll show you one practical programming example also as a part of this session. So, guys, I'll share my screen. Just have a look on this. First, I'll explain you the concept theoretically, and then I'll show you the code also. So, first of all, have a look on my document. So guys, this is a document which I'm maintaining on my LMS, in which each topic, whatever I'm explaining, will have a detailed notes. And if you are looking for the URL for this document, then please do let me know in the comments wherever we are watching this live. So let's try to understand what are VLAs in C language. See, a VLA is nothing but variable length array in C is an array whose size can be determined at runtime instead of compile time. That's nothing but at runtime, you can give the size of the array. So, unlike normal arrays with a fixed size, in general, like earlier, we used to declare array at the time of compilation only, and whatever the size you have given, that is fixed. But the VLS concept has been introduced from C99 version onwards. So it will allow you to declare an array at runtime with a given size. So you can see the code here. I have declared one variable called n. I am reading the value of n, and then I am declaring an array with the given n size. This is what we call VLA. So if you are coming from like old IDEs, that's nothing but if you have practiced C language in old IDEs like Turbo C and Turbo C++, then this piece of code will not work on those IDEs. Remember that. And the memory is allocated on stack, but not on the heap. Like though it is allocating the memory for the array on runtime, the memory will be allocated on the stack, but not on the heap. If you allocate memory by using malloc function, then the memory will be allocated on the heap. Okay, and the scope is limited within the function in which these VLAs are declared. Means whenever the control comes out of the function, automatically the memory which is allocated for that particular array will be removed. And VLS cannot be initialized at the time of declaration. Means you have given size, okay, and you are initializing with some data. This is not allowed in VLS. Remember, and we can pass the size as well as the array as a parameter to the function also. This is possible. And I have given one example program here. Okay, so what I'll do is I'll just show you this piece of code. Okay, and there are some limitations for VLS. Try to read those limitations. This is very important. It is not supported in all C standards. That's the thing, but all the compilers are not supporting VLS. Actually, in C99 version, they made it mandatory, but after later versions, like in C11, it has become optional. So every compiler is not implementing VLS. So the VLS concept may work with few compilers and may not work with few compilers. So you have to be careful while working with VLS. As it is consuming stack memory, and stack memory have always a size limitation. So there is a risk of stack overflow for large sizes. And you cannot use size of at compile time. So size of VLA works but evaluates at runtime. So should you use VLS? See, VLS are used for small arrays but not for large volumes of data. So if you want to work with large volumes of data, then it is always recommended to go with dynamic memory allocation, and that's MLOC. Using MLOC, you have to allocate the memory, and using free, you have to deallocate it. So if you want like practical examples on MLOC and free, then please do let me know in the comments, so that I'll just prepare some reference material, and I'll give you example on MLOC and free also. An alternative for VLS. Imagine that if your compiler is not supporting variable length arrays, then the best alternative for VLS is the dynamic memory allocation. So this is how we have to allocate the memory. Okay, using MLOC function. Once the job is done, free that memory by using free function. But today's our agenda is working with VLS. So what I'll do is I'll just copy this piece of code instead of writing the whole code again. So here this is our id. I'm using code blocks id, guys. Okay, so here you can see I have declared one variable with the name n, which is of integer type. After that, I am reading the array size from the user. User will input one number, okay, say for example 20. Then I am declaring an array with that given size. So this is what we call actually the VLA declaration. Now, you might have worked with this concept earlier in your academics, but you may not be familiar with the terminology. So, in interviews, sometimes the terminologies are more important. Why? Because if someone asks you, hey, have you worked on VLS? Then you may think that VLA is a new concept and you are not aware of it. But it's a so simple concept only. And you can read elements into the array and you can simply display it. So as it is a simple code, I've directly used the copy paste to explain you the concept in order to save the time. So let me run this. So the program is executed. It's asking the array size. I'll say like, for example, 10 elements. Then you'll enter the 10 elements here. Once all the 10 elements input is finished, it will display all the 10 elements. So guys, this is about VLAs in C programming language. And please do let me know in the comments that you understood this topic or not. And are you aware of this concept earlier? Means you may be aware of this concept, but you may not be familiar with the terminology. So whatever it may be, do let me know in the comments. Till then, bye-bye. And in next session, I will come live with one more very, very interesting topic. So guys, thank you so much and bye-bye.